Assalamu alaikum. Hello everyone and welcome back to the good stuff. We are continuing with our chemistry saga. Now we are in topic 2. However, I left the last part of topic 1, which was chemical equations, that will be taught at the end of this topic, either in this lesson or in the next lesson. Now you will forgive me for the past few days. I was out of town, so I haven't been able to upload any videos, but from now on I will be uploading every single day. So without further ado, let's dive straight into our second topic, which is chemical families. What is a chemical family? A chemical family is a group of elements with similar chemical properties. As we learned in topic 1, what is a group? A group is, in the periodic table, are elements with the same number of electrons in the outermost energy level. So we have four chemical families in the periodic table, that is group 1, group 2, group 7 and group 8. These four groups, group 1, group 2, group 7 and group 8, exhibit the same, in their own groups exhibit similar chemical properties. Now group 1 is alkali metals, group 2 is alkaline earth metals, group 7 is halogens and group 8 is noble gases. So alkali metals have alkali metals in group 1 have similar properties, group 2 have their own similar properties, so on and so forth. So we start with our first chemical family, that is alkali metals. Alkali metals is group 1 and we have three metals in group 1 as alkali metals, which are lithium, sodium and potassium. What is the electron arrangement of lithium? 2 1, it is number 3. Sodium is 2 8 1, number 11, and potassium is number 19, 2 8 8 1. As you can see, there is one electron in the outermost energy level, hence group 1 and alkali metals, and they are said to be monovalent because they have one electron in the outermost energy level. So of alkali metals, we will look at various different parts, which we have atomic radius. We will start with atomic radius. Now in chemical families, as I told you, they are elements with similar chemical properties. However, they are in a group. So group 1 has lithium, sodium and potassium with their chemical symbols represented as. So we will look at the trend in how the atomic radius of these elements compare, the ionic radius compare, electropositivity, reactivity and many others. So we will start with atomic radius, how these elements in their own group compare with each other. And we will be looking at trends. So let me draw it again. Lithium, sodium and potassium. Atomic radius. Atomic radius, as we know, is the radius of the atom. It increases down the group. Atomic radius increases down the group due to an increase in number of energy levels. Lithium has 2 energy levels, 2 1. Sodium has 3 energy levels, 2 8 1, and potassium has 4 energy levels, 2 8 8 1. This tells you that the atomic radius of sodium is greater than the atomic radius of lithium, because sodium has more energy levels than lithium. However, the atomic radius of potassium is greater than the atomic radius of sodium. Why? Because potassium has more energy levels than sodium, hence a greater atomic radius. In all the groups, in alkali metals, alkaline earth metals, halogens and noble gases, atomic radius increases down the group due to an increase in number of energy levels. In every group in the periodic table, especially the chemical families, the atomic radius increases down the group due to an increase in number of energy levels. After atomic radius, we go to ionic radius. Ionic radius. Ionic radius also increases down the group due to an increase in number of energy levels. Now, what do I mean by this? When lithium is 281, sodium is 281. Sorry, lithium is 21, sodium 281, and potassium 2881. Now, when these electrons are lost in the outermost energy level, when 2 is lost, when lithium is left with 1 energy level, when sodium loses this 1 electron, it is left with 2 energy levels, and potassium loses the last energy, the last electron, the last energy level, and is left with 3 electrons. So, following atomic radius, the ionic radius of alkali metals also increases down the group due to an increase in number of occupied energy levels. Please note that alkali metals lose the valence electron and hence lose the whole energy level. And this applies to all. So if lithium loses 1 energy level, sodium 1 energy level, and potassium 1 energy level to obtain octet stability, the ionic radius is greater down the group. It increases down the group. From ionic radius we go to ionization energy. Ionization energy. Ionization energy. Ionization energy is the minimum amount of energy required to lose an electron by an atom in gaseous state. What do I mean by this? As we know, a sodium atom has electron configuration of 281, but a sodium ion has an electron configuration of 28. So the energy required to lose this 1 electron to form a stable ion is called ionization energy, the minimum amount of energy required to lose an electron by an atom in gaseous state. So in alkali metals, the ionization energy, let me do this again. Lithium, sodium, potassium. The ionization energy decreases down the group or increases up the group, but you can say decreases down the group. Why is this? Ionization energy depends on the nuclear force of attraction of the atom, and the nuclear force of attraction of the atom in the group depends on number of energy levels and atomic radius. So atomic radius, as we said, of sodium is greater than lithium and potassium is greater than sodium. So it is easier for a sodium atom to lose its valency electron than a lithium atom or a sodium atom. So the ionization energy of lithium is 520, of sodium is 496, and of potassium is 419. Why is the trend this way? This is because lithium has 2 energy levels. There's 2 energy levels, 2-1 electron configuration. Sodium has 281, 3 energy levels, and potassium has 2881. So it is easier for potassium with 4 energy levels and the largest atomic radius to lose an electron due to weakest nuclear force of attraction. Let's put this in writing. Ionization energy, I won't write everything, but ionization energy decreases down the group due to an increase in atomic radius, hence weaker nuclear force of attraction. Thus, the valency electrons are electrons in the outermost energy level. Electron can be easily lost. ionization energy decreases down the group. We are talking of alkali metals. It decreases down the group due to an increase in atomic radius, hence weaker nuclear force of attraction. Thus, the valence electrons can be easily lost. What did we say ionization energy is? The minimum energy required for an atom to lose its valence electrons in gaseous state. So the valence electrons, when they can be easily lost, the ionization is less. When the valence electrons require more energy to be lost, the ionization energy is more. We go to reactivity. I hope whoever wants to write this can write. Reactivity. When a metal loses electrons readily, it is said to be very reactive. When a metal loses electrons, it requires more ionization energy. How does reactivity occur? Reactivity occurs, as we saw in atomic structure. Reactivity occurs by losing electrons with metals. Metals lose electrons and non-metals gain electrons. So one atom loses electrons, another gains, and that is how reactivity occurs. So when a metal loses electrons readily, it is said to be very reactive. The reactivity of alkali metals increases down the group due to an increase in atomic radius. Hence, the atom can easily lose the valency electrons. So the reactivity increases down the group. This means that potassium is the most reactive, sodium is moderately reactive, and lithium is the least reactive. So reactivity increases down the group. Due to an increase in atomic radius. Increase in atomic radius. Hence a decrease in nuclear force of attraction. The valence electrons can be easily lost. So potassium is more reactive than sodium. Why is potassium more reactive than sodium? This is because potassium has 4 energy levels, sodium has 3 energy levels. So the atomic radius of potassium is greater than the atomic radius of sodium. However, greater atomic radius leads to weaker nuclear force of attraction. For example, if this is potassium with 4 energy levels and sodium has 3 energy levels, which one has a greater atomic radius? Potassium, of course, as you can see, it is evident. And which one has a weaker nuclear force of attraction? Potassium, because the protons in this nucleus, find it difficult to hold the electrons in the outermost energy level because they are far from the nucleus. The 4th energy level is farther from the nucleus than the 3rd energy level in sodium. Hence, the protons require the nuclear force of attraction of the protons to the electrons is weaker. So when I tell you that the atomic radius of potassium is greater than that of sodium, I directly mean that potassium has a weaker nuclear force of attraction than sodium. And weaker nuclear force of attraction means the valence electron can be easily lost. Weaker nuclear force of attraction means that the valency electron can be easily lost. There is less energy to the protons in the nucleus, hence the outermost electrons can be easily lost. We go to reducing property. Okay, I will just read this for you. Alkali metals are reducing agents. A reducing agent in chemical families is a substance that loses electrons. The reducing property of alkali metals increases in atomic radius or energy levels. Hence, the atom can easily lose the valency electrons. So, as we talked of the reactivity, the same way reducing property also increases down the group due to increase in number of energy levels. Hence weaker nuclear force of attraction, the atom can readily lose an electron. Hence it is easily reducing, it has a more reducing property. So potassium is a greater reducing agent than sodium, and sodium is a better reducing agent than lithium. Electropositivity, I need you to concentrate. Electropositivity. This is the ability of an atom to lose an electron and become positively charged. We said when an atom loses an electron, it becomes positively charged. Why? Because the protons become more than the electrons. So in alkali metals, electropositivity increases down the group for the same reason. Due to an increases down the group. Mind my words, I won't be writing everything. Due to an increase in number of energy levels, hence the atom can easily lose loses the valency electron and becomes positively charged. So electropositivity increases down the group due to an increase in atomic radius, hence weaker nuclear force of attraction. The atom can easily lose its valency electrons. Our next area is melting and boiling points. MP and BP stand for melting and boiling points. Melting and boiling points decrease down the group due to an increase in atomic radius, hence decrease in metallic bond. Mind this, increase in atomic radius, hence a decrease in metallic bond. Metallic bond because the sodium, the group 1 alkali metals are metals, so hence they have a metallic bond. Now when the atomic radius increases, the metallic bond decreases. Why? Because electrons are further away from the nucleus of the atom. So in general, as we looked at the five areas of study in physical properties, we will now go to chemical properties, but before that we summarize the physical properties. We have lithium, sodium and potassium. What increases down the group? Reactivity increases, electropositivity increases, and reducing property increases. These three increase down the group, as we already gave explanation for them. However, what decreases down the group? We have ionization energy, and the last part which we discussed, melting and boiling points, decrease down the group. So this is a summarization for physical properties of alkali, not physical properties, sorry. No, not physical properties. Physical properties are yet to come. These are just the areas discussed in reactivity, electropositivity, reducing property, ionization energy, melting and boiling points of alkali metals, the trend in the group. Now we go to physical properties of alkali metals. Physical properties of alkali metals. So, physical properties of alkali metals. We have four physical properties of alkali metals, which are: number one, they are soft metals, hence can be cut with a knife or scalpel. Now, if you go to your laboratory in school and ask the technician to give you a piece of sodium metal, you can feel it and you can experimentally cut the metal. The second property goes to the links directly with the first one. They have a shiny metallic luster, especially when freshly cut. So if you cut a sodium metal, a piece of sodium metal with a scalpel, because it is soft, it can be cut, and when it is freshly cut, when you look at the surface of the metal, you will see a shiny metallic luster. However, the luster becomes gradually dull due to the formation of an oxide layer. Sodium will react with atmospheric oxygen to form sodium oxide. Now that oxide layer gradually makes it dull. However, when freshly cut, it has a shiny metallic luster. Number 3, it is less dense in water, less dense than water, hence floats. Sodium, potassium, lithium, they are less dense than water, hence when you put them in water, they will float and dart on the surface. They are good conductors of electricity due to presence of delocalized electrons. Sodium, lithium and potassium, alkali metals, have delocalized electrons. As we saw, the valence electron also, hence they are good conductors of electricity. We go to chemical properties. Note this, I am not writing this, but note this. Alkali metals are stored in oil or paraffin to prevent them from reacting with atmospheric oxygen and moisture. Alkali metals are very reactive with atmospheric oxygen and moisture, hence they will form oxide layers. That is why they are stored in oil and paraffin, from preventing them from reacting with atmospheric air and moisture. We go to chemical properties. Our first chemical property is reaction with water. Now, when an alkali metal reacts with water, it forms a metal hydroxide and hydrogen gas. So, if sodium reacts with water, it forms sodium hydroxide and hydrogen gas. We can write this in words. Sodium, okay, you can just follow me. Sodium reacts with water to form sodium hydroxide and hydrogen gas. We can write the state symbols, sodium, but we have not learned chemical equations, which will be taught at the end of this topic. With symbols, sodium hydroxide is AQ and hydrogen gas is gas. Now we won't balance this for now, but we will learn balancing at the end of this lesson, as I said before, at the end of this topic. So reaction with water, alkali metal, when an alkali metal reacts with water, it forms a metal hydroxide plus hydrogen gas. Now that's our first chemical property, reaction with water, and this is the equation. However, we need to know how sodium reacts with water. This is because it is frequently tested in the exam. So I will read this for you. Sodium floats in water as it is less dense than water, darting around due to vigorous reaction. Sodium floats in water due to it is less dense, and it darts around due to vigorous reaction. It also produces a fizzing sound due to production of hydrogen gas. Production of hydrogen It melts and turns into a silvery ball since the reaction is exothermic. It melts and turns into a silvery ball. Since the reaction is exothermic. What do I mean by exothermic? The reaction produces a lot of heat. Exothermic means the reaction produces a lot of heat. So that heat produced in the reaction causes the sodium metal to melt and turn into a silvery ball. It finally disappears. So this is 1, darts around is 2, fizzing sound is 3, melts and turns into a silvery ball is 4, and it finally disappears due to its reaction with water. When you put a sodium metal in water, you can do this experimentally in your lab. You will see that it floats. Why does it float? Because it is less dense. You will see that it darts around. On the surface of the water, it will move around. So why is it? Because that is due to vigorous reaction. You will hear a fizzing sound. Why will you hear the fizzing sound? Due to production of hydrogen gas. It melts and turns into a silvery ball since the reaction is exothermic. Exothermic means the reaction produces a lot of heat. Hence the heat causes the metal to melt and turn into a silvery ball. Number 5, it finally disappears since due to its reaction with water. Now these arrows represent due to floats due to being less dense, that's around due to vigorous reaction, fizzing sound due to hydrogen gas production, melts due to exothermic reaction, and disappears due to reaction with water. So you can be asked in your exam, a piece of sodium metal was placed on the surface of water. Explain what happened or explain your observations, 3 marks. So or 2 marks. So you will start the sodium metal floats on water and you will explain why, because it is less dense than water. 2, it darts around on the surface of the water because it has of vigorous reaction. It produces a fizzing sound due to production of hydrogen gas. It melts and turns into a silvery ball since the reaction is highly exothermic, produces a lot of heat, and it disappears finally due to its reaction with water. Now sodium is just an example. You can use lithium. Lithium is the same reaction. Lithium plus water is lithium hydroxide plus hydrogen gas, but lithium reacts less than sodium. However, potassium reacts more vigorously than sodium. Why? Because potassium, as we saw, its reactivity is higher than sodium because its atomic radius is greater, hence it can easily lose its valency electrons. Reaction with air. Let's remove this. Reaction with air. Metal, alkali metal plus air. Air, it reacts with oxygen part of air, so you can say oxygen to form metal oxide. Or alkali metal can also react with the nitrogen part of air to form metal nitride. So in this case, we will use the example of potassium. Potassium can react with air, can react with oxygen to form potassium oxide. However, the same potassium can react with the nitrogen part of air to form potassium nitride. Or sodium can react with oxygen to form sodium oxide, or sodium can react with nitrogen to form sodium nitride. So how does lithium react with oxygen? Lithium Li solid because it is a metal. It reacts with oxygen or 2 gas to form lithium oxide. Now how is lithium oxide written? We learned in atomic structure, lithium valency 1, oxygen valency 2. So you cross 2 here and 1 here. So this will be Li2O. Li2O. So lithium oxide is Li2O solid. Now we will learn balancing, but however we can balance 2 atoms of lithium causes us to write 2 atoms of lithium, 2 atoms of lithium. However, here there are 2 atoms of oxygen and there are 1 atom of oxygen. So 2 oxygen combined with 2, and however now these are 4 lithium. So you will put 4 here. Let's look at the flames with which alkali metals burn or ignite or react. Lithium, sodium, potassium. The color of flame. Lithium has scarlet red color of flame, scarlet red. Sodium has golden yellow color of flame, and potassium has lilac or purple, but in chemistry we use the term lilac. When you put a piece of alkali metal on a spatula and burn them in a Bunsen burner, these are the flames you will get. For lithium you will get scarlet red, sodium you will get golden yellow, and potassium you will get color of flame lilac. So as we saw, metal plus oxygen is metal oxide, metal plus nitrogen is metal nitrate. Now how do you distinguish a metal oxide and a metal nitrate? Of course we are talking only about alkali metals. You dissolve metal oxide, you react it with water, and metal nitride you react it with water. So an oxide of an alkali metal, when a metal oxide, let's say sodium oxide, Na2O, I'll just be using formulas for easier writing, reacts with water, it will form a metal hydroxide. And as we saw, the valency of hydroxide is OH, valency 1, and the metal here we used is sodium. So sodium is also valency 1. So if you cross these two, 1 and 1, it's just one atom. So this is sodium hydroxide, AQ, because it has reacted with water. Sodium oxide reacts with water to form sodium hydroxide. However, a metal nitride, let's say sodium nitride, sodium having valency 1 and nitrogen having valency 3, when this reacts, this will be Na3N. So this is sodium nitride. Sodium nitride reacts with water. Sodium nitride reacts with water to form sodium hydroxide plus, this is the difference. This is where the difference is coming from. Sodium oxide reacts with water to form sodium hydroxide only. However, sodium nitride reacts with water to form sodium hydroxide and ammonia gas. NH3. Are we getting it? Sodium oxide reacted with water to form sodium hydroxide. However, sodium nitride reacted with water to form sodium hydroxide and ammonia gas. This is where you can distinguish the two. However, these two hydroxide, sodium hydroxide or potassium hydroxide, the hydroxides of alkali metals are strongly basic with a pH of 12 or 13. And the sodium nitride reacts with water to form sodium hydroxide and ammonia gas. So you will see the effervescence of a colorless gas which turns moist red litmus paper to blue. Ammonia gas is the only gas that is basic in chemistry and high school studies. Ammonia gas shows effervescence that changes moist red litmus paper to blue. When heated in excess oxygen, alkali metals, metal plus O2 is oxygen, excess forms metal peroxide. So sodium, I'll just be using example of sodium or lithium or potassium Na plus O2 forms Na2O2. This is the formula for sodium peroxide, as we learned the formulae of special compounds in the previous lesson. Potassium is the same. Potassium having valency 1 reacts with O2 sodium to form K2O2 peroxide. This peroxide reacts with water to form hydroxide and oxygen gas. Now note this. Alkali metal oxide reacts with water to form hydroxide. However, alkali metal peroxide, which has reacted with excess oxygen, when dissolved with water, it forms hydroxide and hydrogen gas and oxygen gas. So alkali metal oxide K2O2 reacts with water to form KOH plus oxygen gas. You can put state symbols over here, AQ, liquid and solid. The same can be for sodium. Sodium peroxide reacts with water to form sodium hydroxide plus oxygen gas. Now we will learn chemical equations at the end so we can balance them. Reaction with steam. Reaction with steam. Alkali metals are not usually reacted with steam because they react explosively. Sodium and potassium are highly reactive, hence with steam they react explosively, it can cause an explosion. However, lithium reacts moderately with steam, so lithium is the only alkali metal that can be dared to react with steam. So the setup is kind of something like this. I'm not an artist, but we can try. So this is the steam over here. We can have lithium metal over here, lithium, and this is sand. Okay, or wet sand. So, and this is the method of gas collection. What are we collecting? Hydrogen gas. And hydrogen is less dense than air, hence it is collected by upward delivery or downward displacement of air. So wet sand is heated first to generate steam. Reaction with steam. What generates steam? You cannot have steam directly. You have to heat wet sand, which will generate steam. Now steam is generated. However, the wet sand is heated first to generate the steam, to remove any air from here, to prevent lithium from reacting with oxygen to form lithium oxide. Write this down. Wet sand is heated to generate steam. Wet sand is heated to generate steam, which expel air. Hence, prevents formation of an oxide. Wet sand is heated first to generate steam which expel air, hence prevents formation of an oxide. Which oxide? The metal oxide. Let's say lithium oxide. So then when wet sand has expelled air, then now only when steam is passing, lithium reacts with steam to form lithium. Lithium reacts with steam. Steam is water but in gaseous form, water vapor. So H2OG to form lithium oxide. Lithium oxide, solid plus hydrogen gas. Which gas is collected over here? Which gas is collected over here? Hydrogen gas. So this is the reaction of alkali metals with steam. The gas collected, hydrogen gas, burns with a pop sound. That is the chemical test for conformation of hydrogen. Reaction with chlorine gas. Reaction with chlorine gas. When there is a gas here of chlorine and a spatula, we can have a sodium metal here, a piece of sodium here. This is sodium metal and this is a gas here with chlorine gas. So this is chlorine gas and this is sodium metal. So alkali metals react with chlorine to form alkali metal chloride. Metals react with chlorine to form metal chloride. So sodium will react with chlorine to form sodium chloride, which is white in color. So the observation on this spatula, you will see a white solid is formed, which is sodium chloride. So sodium Na to bracket S reacts with chlorine to form sodium chloride. Now sodium having valency 1 and chlorine having valency 1. If you cross these two, you have sodium chloride. So this is how sodium chloride is written. So common formulae of compounds of alkali metals. So we have the elements, we have the ions, hydroxide, oxide, chloride, sulfate. Element number 1, lithium. Lithium ion is Li positive with a charge of positive 1. Lithium hydroxide. Now for lithium, if one is for lithium, then all of them follow the trend. So lithium having valency 1 and hydroxide radical having valency 1 combine to form lithium hydroxide. However, lithium oxide, lithium having valency 1 combines with oxygen having valency 2. So the 2 of oxygen crosses to the lithium, hence lithium oxide is Li2O. Lithium chloride, chlorine having valency of 1, lithium having a valence of 1 directly to combine to form lithium chloride. Lithium sulfate, sulfate having a valency of 2, lithium having a valency of 1 combine to form lithium sulfate. And the same for sodium and the same for potassium. So you can kindly copy this table down and we can go to the last part of alkali metals, which is uses of alkali metals. Uses of alkali metals. So we have various uses, but we won't write all of them. However, if I mention them and you can write them, uses of alkali metals. So you can write them down as I speak. Sodium chloride. Sodium chloride is used as a food additive. What is sodium chloride? Common salt, the salt that we put in our chips, that is sodium chloride. Sodium vapors are used to give a yellow glow. street lights. So the street lights that you see, and you see the yellow color of the light, what is that inside? Sodium vapors are the ones giving the yellow glow. Sodium carbonate is used to soften hard water. Sodium carbonate is used to soften hard water. Sodium and potassium nitrates are used as fertilizers. And I can read the others to you. Lithium is used to make batteries for laptops and watches. Lithium is used to make batteries for laptops and watches. Lithium fluoride and lithium chloride are used to make glass. Lithium fluoride and lithium chloride are used to make glass. Sodium hydroxide is used to manufacture soap. A mixture of sodium and potassium alloy. Sodium and potassium metals, when you make an alloy of them, can be used as a coolant in nuclear reactors. So, and that brings us to the end of alkali metals. In our next lesson, we will learn chemical equations and alkaline earth metals. Until then, goodbye, take care, thank you for watching.